Hi, my name is Hw2 Ai Tsp. This is my video demonstrating my genetic algorithm for the traveling salesman problem for Dr. Fernandez's artificial intelligence class. Okay, Professor Fernandez wanted us to have it create new cities on every run, so I just took out those 2 lines of code, which will do that. And now if we run it, let's go for 10 runs. Okay, so let's start. How many generations? 100 generations is good. Okay, so the first box over here is going to show you all the fitness scores separated by commas if you want to transfer it to a program like Excel. This one is going to show you the current fitness score. Here you have the work done, which is the number of times it called the fitness function. Here you have the runs. So we set it to 10 runs right now. It's going to count from 0 up to 9 or 10. From 1 up to 10. It's at 0 right now. Here's the fitness scores. There's going to be a list box over here with all the fitness scores one by one. Here's the mean of all the fitness scores and the variance. These are all updated every run. And here's the progress bar. Along with all this, I used what I learned in the graphical application development class, and you're going to see a map over here of the route needed to be taken by the traveling salesman, hitting every city. So let's just get it going. Okay, that's the first run going right now, and here we go. So you see the fitness scores are being added on over here. They're rounded to 4 decimal places. Here's the current fitness score. And then over here you have a list of all the fitness scores. Now they're varying because it's a new set of cities every time. As you can see, the cities are changing. The black rectangle is the first city. It doesn't have to be. The way the problem works, you can really start anywhere. I just said, just for making it easier, I put it there so you can actually trace your way all the way back. But you can really start anywhere and you can end anywhere. We just hit our 10 runs. Here it shows you the mean, and here's the variance. Here are the different fitness scores, and we just went for 100 generations. So yeah, it's pretty neat. I like the map I did over here. It shows you all the cities, it connects them. Now for the statistics, what I did it for 100 generations. I did a population of 1,000, and here are the results I got. And what I expected to get in my hypothesis was that the second sample, what I did, the difference between first and second sample, you can see over here in the G file, the probability of gene mutation. It is at 0.01, and I changed it for the second sample to 0.1. So I bumped it up a little bit, so there's a higher probability that the genes will be mutated. Now, I expected that to give me better fitness, but it turned out not to give me better fitness. It was actually higher. So I would not accept the alternative hypothesis. That being said, let's run it the way. So now it's being run that way. Let's change it to the one for sample 2. Okay, hold on. The program is still running, so let me just end it. And let's change it to 0.1, which is what sample 2 was. And now let's run it. Again, we're at 100 generations. We could go more or less, but 100 seems fair. And we're going to run it. It's going to run 10 times. And now the probability of gene mutation is 0.1 as opposed to 0.01. So if we run that, it's creating a new batch of cities every time. We have the list of the cities again over here. We're on run 4. This is a work done, which means the amount of times the fitness function is getting called. So our average over here is about 25,000, looks like. Yeah, we have 25,779. That's our average here for the fitness, which is higher than what we previously had. Okay, and here you see the map of everything. So that was a change that I made. So here's my statistics sheet. I did it 100 runs, 100 generations, and I did 50 runs. And you can see that the difference. The first one where the probability is 0.01, we had 23,000 fitness, 23,754. And the sample 2, we had 24,733, so we don't have an improvement here. That's why you wouldn't accept the hypothesis, the alternative one. But because it's 95%, I guess you don't reject the null hypothesis either. That being said, I had a lot of fun with this assignment. I added a lot of little bells and whistles here. I think the map is really cool. If you really want to see the evolution, first of all, let's put it back to, okay, again, I forgot to close it. Let's put it back to 0.01. And over here, it's basically generating a new set of cities every time. But if you really want to see the evolution, you take this out. So it keeps the same cities, but you see it evolving. So let's run it now, 100 generations, 10, and you will see the difference. So we start off just like before, 22,000, but immediately you see an improvement. We're at 17, we're at 14, 13, 12, 11, and we're only on the 8th run. So we're ending with 11,110.98. Much better than before. As you can see, the first run is what we saw before when we changed the cities every time. It was at 22,000. But if you actually let it keep going and evolving, then you see an improvement because, like I said, it's evolving and it's keeping only the best solution. So after 10 generations with a population of 1,000, after 10 runs with a population of 1,000 and 100 generations on each run, we're at 11,110.98. And this is nice to see also when you don't change it because the map doesn't change, only the lines do, so you can see it's exploring all the different paths. Yeah, so I had a lot of fun with this assignment and hope you like it. Thank you very much for watching.